Yeah, you'll have to get to this. The power's probably coming through the wall on here. There's no power.
No power connected?
Oh, there's power, I just don't see the fuse. Maybe there's no fuse. Maybe they don't have fuses on this one. Seems weird though. No, well. Yeah, I usually see fuses here. But it says it's coming from a panel. It's 30 amp circuit on the writing on here. Well, we'll see. Somebody brought panel power into here from through the wall because there's a conduit
Right.
bus, so that's okay. This is 30 amp. Yeah, they could bring another set of wires into here and change this box and split the power and come into two.
For putting,
If you wanted to power both of them independently. Right now, you just have to plug and unplug. You plug one, plug the other, because you have the same can of plug down here as you do here. Shoot. That's still off. And it will reach. You know, so should be fun.
we need to worry in case if we are running both simultaneously, but I don't think that kind of demand we have.
Yeah,
Not a big issue.
easy bridge across whenever that time comes.
Alright.
It's not a requirement, especially if you're only doing 1 or 2 depositions a week. This is fine.
No, I don't think even we do that for the time being.
But you can refill and check the level here.
The opening.
Yeah,
Any can be open.
Huh?
Anyone can be
Yeah,
open.
they both go to the same place.
Yeah.
And if this gets dirty and you're changing oil, you can take the Cyclops off and clean it,
Okay.
and then put it back on there. It's just a ring seal. They're good pumps. Good pumps for this use. If you get into the point where you're running it every day, then we would recommend having a different pump.
Bigger.
Well, they have a bigger pump and they have filtration on the pumps. But unless you're running them every day,
That's
this is fine.
For example, I was here for the last 1 month. We never run PVD. I think maybe since installation, maybe it ran once.
Yeah. Now PVD is good, but it's limited to the direction. ALD is conformal. So you could do like high aspect ratio materials, like up to 1 to 2500. You know, really long traces, small little narrow passages. You can have a uniform coating with the ALD because it's a self-limited reaction. So you'll have the same thickness all the way around. This, you can't do that. So in the case of microprocessors, we're just about at the limit of being able to go two-dimensional. We can't go smaller, two-dimensional. Now for storage and space, we have to go three-dimensional. This won't be three-dimensional chip.
That's two-dimensional.
This cannot be three-dimensional. Two-dimensional. This could be three-dimensional. Three-dimensional as far as building on a structure. It can't not do a three-dimensional figure.
So you told me that the PVD has a problem with uniform coating?
No, it'll do uniform coating over, when the factory testing, we do uniform on a flat surface. Two-dimensional uniform coating 6 inches is great. If you have a big long trough that's really, really narrow, or you have a structure that has a bunch of holes in it, that will do a good coating on the surface, but inside the holes, maybe not so much. You know, so if you want the same thickness on this dimension as this dimension, you have to use a different process, different method. But this is much faster. This is slow, really slow.
It's atomic level.
For example, aluminum oxide, which is a very well-known process. Aluminum oxide on the heater, substrate heater is set at 332 degrees C, then the substrate sample itself will be 300 degrees C. The H2O TMA to build aluminum oxide is about 24 seconds. 24 seconds, if everything is correct, will give you a film build of 0.84 angstroms per cycle. So 0.84 angstroms every 24 seconds.
That's very small.
Very small. I made the comment one
It's
time.
even in angstrom, not even in micrometer or something. No.
No, it's very small.
Gosh.
So it takes hours. Whereas I made a comment one time to somebody says, whenever the graph is running, it says, oh, it's like watching grass grow. Then I looked, grass grows a lot faster.
Obviously, yeah.
So, not the best analogy. But it's a very neat process. You can run a process for 2 hours, take the wafer off, and you still won't be able to visually see.
Even after 2 hours.
You can see, you might see a color differential because oxides have a myriad of color changes that repeats. So like after 1,000 cycles, you should have like a purplish. 200 cycles, 300 cycles, you have a faint blue. You'll see a discoloration on the first few times between the heater and the sample. But you won't be able to see it. You can measure it with do you have an ellipsometer here?
What's that?
Do you have an ellipsometer?
Do we have plastic? No.
Well, what does it look like?
That's the way how to measure the whatever done on this machine.
Ellipsometer?
Ellipsometer, yeah.
You don't have one. It's okay. You might end up getting one later on.
We'll ask.
We sell, if you're going to be doing films with this all the time, you're probably going to end up needing an ellipsometer. You can measure characteristics, but you won't be able to see the film. Ellipsometer, I think we sell an FS1 ellipsometer. It's a very useful ellipsometer on a nice little platform. It's usually about 10 grand versus a Woolham, which is also an ellipsometer that uses a lot more channels. The FS1 only uses 4 channels, but it's also 10 times less. So, if you get to that point at some time in the future, then we can talk about it and options. But let's get you there first. Let's get you up and running. So depending on the thickness, you may or may not be able to see it.
So
You can measure it through
What's your passing color
resistivity.
you?
Good. What?
You'll be able
How
to
was
see a
the
change
exam?
through resistivity.
Good.
Okay.
Yeah, great.
Good cameraman.
Yeah. One thing good for today.
What's that?
One thing good for today is the camera, man. I think that's recording.
Is it recording?
I might have to borrow a